All righty. Okay, so yeah, a couple of you have emailed wondering about Quiz 4. I with grading other stuff and that, I just kind of got behind on that quiz. Not sure what exactly we'll do about it. You might get it at some point and be given some time to do it, or we might skip it. You probably wouldn't mind that, I suppose, but something with that. And in the meantime, we've gotten some of the things for Module 5 opened up. The project's not there yet. It's going to be a template again, an analysis of variance template that then you'll use to analyze some data from the NPR. I think it was an NPR podcast that on music. That some of the background's already there, but I have to get that project set up to where you know what to do. I think the discussion's open now. When I first did it, I didn't actually. So I opened up Module 5, but that doesn't automatically open up the discussion. So you couldn't get to it at first, but I think you can get to it just fine now. So we're moving on to Chapter 4. Does anybody have any questions about anything right now? Guess I'll take that as no. And so as we move into Chapter 4, I want us to look at sort of just what's different between Chapter 4 and Chapter 3, because we're at this point now with these particular chapters that we really should be saying, in essence, oh, we're solving that same darn problem again. Okay, so I want to highlight how they're similar. And so before I talk about the beginnings of Chapter 4, I just want to look at an overview of how they can be similar. So in Chapter 3, we could have gotten a data set that looks something like this, where, say we're talking about corn. You maybe were interested in fertilizer types or something, right? You want to grow corn. We're in a rural area, agricultural area. You want to grow corn, and so you may do an experiment, and you may have a control where you didn't use any type of fertilizer. And then I'm not sure exactly what these fertilizers are, but fertilizers A and B. And then you might have looked at the yield, and that could have been something like high, medium, low.
Dr. Dillery?
Yeah?
I can't see. I think you forgot to turn your camera on.
That's weird. This is the second time this has happened. Thanks for shouting out.
Sorry to interrupt.
Well, no, that's why I didn't mute you. So, really? Okay. So right now, you're just seeing your screen?
I currently have my camera off. Can you see me now?
Yep.
Okay, all I'm seeing is your name.
Okay, because it says you are presenting, and I could get these people in class to agree that that's what's going on.
All I'm seeing is an S, and like making the movement.
Yeah,
to show that
yeah,
you can
okay, so let me stop presenting and I'll try presenting again.
Okay,
Um,
sorry.
No, okay, so we'll go to present now. And
It showed that you were presenting, but it still only showed an S. It didn't show
that's,
any.
yeah, I don't know. And if that's the case, if it doesn't change, I don't have an answer.
I can try maybe you rejoin.
Yeah.
Would that work?
Yeah, you could try that. So right now, you're not seeing my screen.
No, all I'm seeing are two S's. It shows your presentation and.
Huh. So yeah, rejoining, seeing if that helps. And if not, I think the answer is I am taping it, so I will have that video available tomorrow sometime probably.
Okay, I will try rejoining.
Yeah. So let's do that. See, I've even got witnesses, right, that when it came up that, you know, it did say I was presenting, so.
No, I don't think it worked.
Bummer.
Say that your video's off.
What's that?
Like if you like scroll down to where it has like camera and stuff.
Oh, right, the camera is off. I'm not sharing the camera, but I'm sharing the screen. So, because yeah, if I tried to share the camera, then all hell would break loose. It wouldn't work right. But of course, it's not working right now. Okay, so yeah, I don't. Yeah. So I guess you know, you can check the video when it's done because I have no other answer at this point. So I'll look into it for future things, but that's kind of weird. Okay.
Okay.
Sorry about that.
It's okay.
Okay, so we'll go back to this though. So, okay. Yeah. Huh. Don't know what's going on there. All right, so fertilizer type, and we could have data that, you know, were something like this, where, you know, these are maybe parts of the field or something along those lines, you know. They maybe broke a field or a number of fields up into a mosaic of some sort and put the different fertilizers on and got these results for high, medium, low yields. And, you know, something like this, you know, we're asking, you know, the general idea is, are these two variables, fertilizer and yield, independent or dependent, right? Is the fertilizer actually doing something to the yield? And actually, as I look at it, it looks kind of like it is, right? Because this is kind of bottom heavy with low yields here, and these are at least similar across, or maybe even a little higher in the medium and a little higher in the high. You know, so they don't really look like that first column. So, you know, I would say just as I look at the data, I think, oh yeah, you know, this there's probably something going on there. So, you know, that's just asking independence versus dependence. But another way to look at this is, you know, we're asking, our null hypothesis says, well, all columns have the same relative frequencies or distribution. Okay, there's about the same proportion of high, medium, and low in each one. Not 1/3, 1/3, 1/3, but that across this way, the proportion would be the same no matter which column I'm in. And, you know, alternative hypothesis, at least one column is different. Okay, so that's another way to put the independence, is if they all have the same relative frequencies, you know, each column has the same relative frequency, then things are independent. Because it doesn't matter which column I'm in, I would expect the same high, medium, and low proportions. But the alternative would be at least one of these columns is different, which would mean, oh, fertilizer somehow changes the yield. Oh, okay, so at least one column is different. And so that's what we would have done and dealt with in Chapter 3. Okay, now, when we go to Chapter 4, okay, what happens is, so here, both these variables are categorical. Okay, and probably I would consider the fertilizer as the explanatory variable and the yield as the response. Would make sense. So in Chapter 4, what happens is explanatory is still categorical. Okay, but response is numerical. Okay, that's what changes. And so, if we were to look at data from something in Chapter 4, dealing with this same idea of fertilizer and so forth, so with Chapter 4, you know, we'd have our corn stuff and fertilizer type. And we would still have none A and B, but now our response variable on the yield might actually be something like bushels per acre. And I took a quick look in Wikipedia or somewhere like that and thought, you know, what kind of yield do you get from corn? And you know, it looks like typically corn yields are things like on the order of 100 bushels per acre up to 200 plus bushels per acre. Yes?
What constitutes a bushel? I've heard that all my life, and I don't know what it is.
That's a basket about that big around, about that tall. So yeah, you know, if you go back in the day, truly, when you'd go to an orchard and you get a bushel of apples, it came in a basket like that. I don't think it does anymore. Not like we go to a couple orchards north of Campbellsville and they come in plastic bags. Okay, but yeah, a bushel is just a particular volume measurement. And that seems a little big for a basketball hoop, but you know, the old idea of the initial beginning basket, you know, when basketball was invented and so forth, they just put some sort of basket, I mean a true basket, like a bushel basket up on a pole and had people throw the ball into it. Anybody know the name of who's credited with the founding of basketball? I think it's like Naismith or something like that. James Naismith. Yeah, just, you know. Hey, we're here to learn more than just math, right? So, I think that's named something like that. But at any rate, so bushels per acre. And so kind of trying to reflect what I see here, High might be stuff at 200 bushels plus. Okay, so maybe your data here, you had one plot that produced 205 bushels per acre, and then some others like 165, 160, 145, 140. Well, and maybe things somewhere around 150 are considered medium, and so I made 4 of those. And then if I can fit them on here, 100, 95, 95, and 90, and, well, it goes down. So I don't have room for my last 2. So, that might be how your data are numerically. And then similarly here, maybe you had a 215 and a 210 and a 205 and another 205 and a 200. And you see there's 5 of them that maybe are these 5 high ones here. Right? And then you'd have more data down this way. And you'd have something similar here. Okay, there's the change. Chapter 3, Chapter 4. Okay, it's the same question. Do these fertilizers, does it matter? Is there something different about fertilizer A or fertilizer B or both fertilizers compared to no fertilizer, right? Is there something going on between fertilizer and yield? Same question, different data form. Now, I could make these data out of this data. I can't really, if you only gave me that, I really couldn't tell you this. Right? So by, here we tend to have a little less information. Right? This is giving me a little more information here because I know the actual yields of each one. Here, I just know what category they fell in. Right? So all these highs could have been just barely high, or they could have been really, really high. I don't know. Okay, so I've got a little more information here, but it is exactly the same idea. Any questions about that? I mean, that's a big deal to me in this course, is just realizing that, yeah, Chapter 3 and Chapter 4, they're the same thing. We're asking the same darn question every single time. Okay, and the difference is, well, my data might have looked like that. Now, the raw data, might have been check marks or high. It might have been for this field, it would have had an H or something like that for high yield, an M for medium yield or something like that. Whereas this would have probably looked a whole lot like that, just to begin with. Okay. Questions about just the data part of it and what's going on there? Okay, so this really wouldn't probably be your raw data file, okay, but this is how you could represent it. This is a nice visual representation of our count data, our categorical data. Now here, this is not a nice visual representation. It is visual, I guess, but to get something kind of like this table that's a little bit nicer visual, this is where box plots come in, right? I could have, oh, well, I forgot though, before I put the box plots, I didn't put, here I put my null and alternate hypothesis. So here, all of a sudden, one way, now there are a lot of ways to state the null hypothesis with count data. Because it really, I said columns. Well, I could have said rows instead. Really didn't matter. With count data, the mathematics doesn't know which is the explanatory and which is the response variable. Okay, you do, but the mathematics doesn't. Whereas here, because they're different types of variables, oh yeah, the math knows which one's explanatory and which one's response. Okay, explanatories are my categories, and then the response are my numerical values. Okay, but here, when everything's categorical, we don't know the difference, so that could say columns or rows. But I use columns because these are in columns. And that's typically how you would see your data, would be like that. And so the null hypothesis here would be, I could state it very similar to that. All columns have the same mean. Really similar. I mean, here, relative frequencies. Here, same mean. And any given one of these frequencies you actually could think of like a mean. Again, I don't know if I'll ever convince you of that, but I'm convinced that frequencies are just means, they're just averages. And so, pretty much the same thing. And then the alternate is at least one. Do it just like I did that one. At least one column has a different mean. Okay, so really they're asking pretty much the same darn question. And I'm sure I sound like a broken record, but it is that important. That you get a much, much better idea of what's going on with all this if you can kind of commit this notion to your intuition, that these two tests are really just the same thing. You just have to deal with them mathematically differently because the data are represented differently. You just, you can't go at them the same way because they're not made the same. Okay, this with these numbers in there that way, much different than counts, bean counts. So we have this. Now visually, what we can do is we can set up some box plots to represent the distributions of those numbers. And again, that's where you start to kind of see this idea of relative frequencies and distributions and all that, is we can do a box plot for these. So we had none, we had A, and we had B. And just kind of looking at how I was doing the numbers and so forth, you might see something in your box plots that looked, oops, missed. There's B. So we do those box plots with our min and max, so minimum, maximum, first quartile, third quartile, and the median. Okay, and we do that for each one. And so that's a lot like our relative frequencies or distribution in the end. Okay, in that it's showing us how things are spread out. Well, that's what those rows showed us. It showed us how things were spread out. And so you can kind of look at this, and the data I was trying to put up there, maybe looks something like this. And as you look at it, you say, there might not be a difference between fertilizer A and B, but there definitely seems to be a difference between fertilizers and no fertilizer. Looks like it. how do we know for sure? Well, for sure, that's always a rough thing. But, how do we decide we have the evidence to say there's a difference? We run a statistical test and get a p-value. Okay, we know how to get a p-value from chapter 3 for count data. And chapter 4 just tells us how to get a p-value for this numerical data this way. Okay, but the p-value again, same idea, right? It's based on the null hypothesis, and it says, how likely could you get data like this if all those columns really did have the same mean? Okay, so randomly select, how often could this happen? And that's what the p-value is telling us, right? Is how often we could get our particular data or something even more weird based on that assumption. And if that p-value is small, we say, well, that couldn't be true. We'll have to go with this. If the p-value is big, I guess we're stuck with this. Doesn't mean we want this or even believe it, but we don't have enough evidence to overturn it. Okay, so again, these statistical tests, the p-value thing is all about getting enough evidence to not believe that. Okay, and it takes not great evidence, because again, it only needs to be less than a 5% chance, but it does need to be at least some evidence, okay, less than a 5% chance. Okay, so that's what chapter 4 is really doing as far as two variables. Now they move into it a little, well, not a little, pretty much like they did chapter 3 again. So I'm going to go ahead and erase this. In chapter 3, they started with just the question of, what's a confidence interval on a proportion? Okay, so I go get some data, I find a proportion, and I ask, well, okay, I know things are random, so whatever I found for that proportion is probably not exactly what the real population is, but, maybe it's close, and I could build some confidence interval for that measurement. Okay, they do the same thing with means, and again, why not? A proportion is just a mean. And so we have a single mean confidence interval. Okay, and let's see, and hypothesis test. And that's how they started in chapter 3. Okay, it's just now we're not just counting successes and failures. Now we are getting numerical data and getting an average. Okay, so then the question is, all right, I got a bunch of data, I get an average. How likely or where is, where are my bounds, my comfort bounds on where I think the real average is? Okay, so again, when we did this in chapter 3, for the confidence interval, right, you did this p plus or minus z alpha over 2 times the standard error. P hat. Okay, there was our data, our proportion. Then we did our confidence interval, typically a 95% confidence interval, so alpha was 0.05. and then the standard error based on our data. So let's, alpha was 0.05 typically, 95% confidence interval. And so that made this number z alpha over 2 1.96. Okay, or again, our rule of thumb for normal distributions, about 2. About 2 standard errors. Okay, because that's all this is doing, is how many standard errors? Oh, about 2. Okay, and that was that rule of thumb, 95% of the population is within plus or minus 2 standard errors. Okay, so that's what we did. And our standard error, the way we calculated that in this case, was we took the square root of p hat times 1 minus p hat divided by n, the number of trials or number of data points that we had, number of observations. Okay, and again, I'm putting this up to show how similar chapter 4 is. I mean, that we're really not doing much different. And so in chapter 4, our confidence interval is x bar, okay, our sample mean, plus or minus. Here's where things get a little trickier. T n minus 1 comma alpha over 2. It's not a z anymore. That's the one big thing that they introduce in this chapter, but we'll try to show how that's similar to chapter 3 as well. Times our standard error. Okay, again, if alpha is 0.05, okay, 95% confidence, our threshold of 0.05, then that 1.96 is the smallest that this number is going to be. Okay, now, actually, that number can be as big as like 12, but I'm going to say 2.5 and put a little asterisk here. And then down here, say, with that asterisk, for n greater than or equal to 7. So if I've got at least 7 data points, this number is never bigger than 2.5. Okay, it depends on n. That's why that n minus 1 is there. It's the degrees of freedom. But it's never bigger than 2.5. Okay, as long as I've got at least a little bit of data. I mean, you get down to n equal 2 or 3, yeah, that's when this number gets really big. But, if you got 3 data points, why are you taking an average? I mean, just look at the 3 data points, right? You don't need no stinking average on that. And so we have this, the standard error looks a lot like this standard error, in that it is the standard deviation of my sample, S. Okay, so the sample standard deviation that we can just calculate from a spreadsheet or something like that, divided by the square root of n, just like this is divided by the square root of n. Okay, they're very, very similar. And again, x bar, the average. What do you do for an average? You take x1 plus x2 plus x3 and so forth to xn, and you divide that by n. And that's how you get an average. Well, this proportion, how did you get p hat? Well, you took, p hat, that proportion is x1 plus x2 plus all the way out to xn divided by n. It's just that those x values are either 0 or 1. I either had a success or I didn't. Right? So to count my number of successes in all this, I just make a 1 on each of those and a 0 on the ones that weren't. Same formula. Different types of numbers, but the same formula. So this really is just an average. It's just a very, very special average. Okay, so these could be any numbers you ever dream of. These have to be zeros and ones. Okay, so that's our confidence interval stuff. The hypothesis test, pretty similar, right? With the hypothesis test, we use a lot of this, we use these same things. But what I'd like to do is go to a template for these things. So here, I stuck with the corn idea. And I said, okay, we've got these yields, bushels per acre, 210, 208, 205, it's over a bunch of numbers. And I'd like to do a confidence interval on it. Okay, well, I have a template for you that you can use. At one point, I thought I'd make you make the template, but no, that seems silly. So I just have a template for this. And all you have to do, so it's here, no, there, confidence interval. So it's set up. You have to put in your data, that's the L equals up there, and you have to put in your level, like 0.095, or sorry, 0.95, like 95% confidence level. So to put in your data, all you have to do is highlight your data here and do a copy. Now here I can do a right click and say copy. But again, when you go into Desmos, you have to simply do a Control V. Okay, Control and V. On a Mac, I don't know if it's the same thing or not. But yeah, Command and V, and it pastes. So Control V, and I put it in, and there it did something. Right, but the graph doesn't really make sense until I put in a confidence level. And so if we go with a 95%, so 0.95. Okay, now it looks like there's nothing there. Well, I should probably put that on projector mode. Okay, now I can kind of tell that there's something there along the x-axis that looks blue. But you're going to have to, unfortunately, I can't find an automatic way to change where the limits are on the graph. Now, I can, if I put this in my own web page, I could make it so it automatically updated. But I can't find a way to do it within the Desmos page. And so you just have to try to zoom to find the picture, okay? Now, we'll go find the picture, and we can do that pretty easily by going here. Just scroll down. Here's the mean, 163.16. Oh, okay. So I need to, I'll zoom out a bit. And there is a bunch of stuff. Now, I can end up making this look a lot better. Here's the problem. So it's telling me the mean is 163.16. I'm having trouble reading the confidence interval stuff. I can kind of see it says 149 point something and 176 maybe 0.971. But it's kind of hard to read. Okay, why? Well, because the y-axis isn't scaled well with the x-axis. So all I have to do to scale a little better is go click on the wrench and go to the y-axis, and I'll go from like -1 to 5 and get out of there. And well, yeah. So see, I probably didn't even want to go just to 5, but that's not too bad, right? So I went from -1 to 5, and now I can kind of see what's going on. So what you see is here is the supposed population based on the mean and the standard error. And so it looks like the population looks like this blue curve. And under that, then we would expect our 95% confidence interval to go from 149.3 to 176.9, or about 177 there. And with the observed mean, the sample mean, right in the middle. Okay, so this template will do that for you. And the reason I give you something like this is every time you use this template, I want you to be reminded of what the mathematics is actually doing. Okay, the mathematics is assuming something that looks like a normal distribution. It's actually a t-distribution. But it assumes this t-distribution, that's what our population of means looks like. And then it goes out around 2 standard deviations. Okay, it's usually a little more with a t-distribution. It goes out around 2 standard deviations on either side and says, okay, let's draw those lines. That's where 95% of the population should be. And so I'm going to guess the right answer is in between 149 and 177. Okay? And that's what the math is doing. And that's all it's doing. I mean, that's really, it's kind of neat that it does that, but that's all it's doing. It's saying every single time it builds that population distribution and just asks where do those 95% marks go, so that we've got 5% outside of the marks, 95% inside the marks. Okay, every single time. Now, if it's a hypothesis test, we also have a similar test for that, or a template for that. In this case, well, I need to know my hypothesized mean. So, I don't know, we came up with 163. Maybe we hypothesized it was 170. Okay, and we still need the data. I think I can still paste that data. Yeah, so there's the data. And then it gives me a p-value, 0.316. Okay, and it also gave me a picture. Well, I have to, again, to find that picture, I'll zoom out. I know the mean is around 163, but again, I could come down here and find it. So I know the mean's around 163, so I come out here. And notice I find a real, okay, I'm going to, again, change the scale on the y's. Go from like -1 again to, I'll just go to 2 this time instead of 5. Oh, and so we can see it a little better. Okay, basically the same picture. So that blue distribution on top, it's the same exact distribution. Nothing different than the first picture. The only difference is it's now centered over 170, not 163. That's the only difference. Well, why is it centered over 170? Because that is the null hypothesis. So the null hypothesis is saying, hey, this is our mean, and this is our population spread out like this. And then here, the black dot is our X bar from the data. And the question is, well, is that inside our 95% region or outside? If it's inside the 95% region, we're stuck with the null hypothesis. We don't have enough evidence to reject the null hypothesis. And yeah, it says so right over here with the 31.7%, so almost 32%, that if the real mean is 170, we had about a 32% chance of getting our data. If I had a 32% chance of winning the big lotteries, I'd play them all the time. All right? I mean, 32% chance, that's really good. Basically 1 in 3, right? So of course, sure, I might see that data because I got a 1 in 3 chance of seeing data like that. And so what we have is that this dot is inside that region. But now notice, here's the connection between a hypothesis test and a confidence interval. Notice that if I come back here, 170 right there is inside the confidence interval. Okay, so here, when I build my rejection region, that's anything outside of those lines, I built it really with the confidence interval, making it the same way I did for the X bar data. Okay, all we care about really is the p-value, but the picture is that it's the same thing. Now, if I go up here and change that mean, so it was 170, let's go back here. That's 176.97. So I'm going to change it to 177. And when I do, the p-value should drop barely below 0.05. It's like magic or something. Okay, 0.04955, that I would call that barely below 0.05. And how did I know that? Well, I knew it because 177 was outside of this confidence interval. So I knew since 177 was outside the confidence interval, then 163 would be outside of the null hypothesis region and into the rejection region where I'd take the alternate. Okay? And if it's out in that region, the p-value had to be less than 0.05. But I knew it wouldn't be much less than 0.05. So if I go out here to 180, I guess, that's quite a bit outside. So I can go to 180. And when I go to 180, you see, my data are way out here compared to the null hypothesis. And now the p-value is getting much smaller, 0.0189. Okay, and if I went up to like 200, I'd probably get a really, really tiny p-value. Okay, so the confidence interval hypothesis test, they're really the same thing. They're just, one, with the confidence interval, I'm kind of centering all my attention on my data. And the hypothesis test, I'm centering all my attention on the null hypothesis and asking where the data is relative to that. Okay? But use the templates and look at those pictures. Because again, you know, the calculation, software out there can do the calculation for you. But if you can't get an idea of the picture of what's going on in your head, well then you're really apt to just not realize when you've accidentally put something wrong into the technology. Okay, but most of you, if you end up using much of this in the future, you'll do it. You aren't going to do it by hand calculations. You're going to use spreadsheets and things like Desmos and various stuff like that. You need to understand when it's just spit out a really bad answer, okay? Because somebody somewhere put an error into it. You know, so you want to know what to expect just by looking at the data and by kind of thinking about things visually. And so I really suggest you spend time thinking about these templates and what they look like. And that, I hope, helps you with the more complicated things that you can't truly visualize. You just have to kind of put the data in and go, because you can't see them very well. Okie doke. Today is Thursday, so I'll see you next Thursday. I'll be trying to get caught up on putting some stuff up there for you, but also on grading, getting some grades done for you so you can see more about what's going on with that. I'll figure out what's going on with the quiz too, you know, whether we'll have you just do that or skip it or what. But okay, I'll see you next Thursday.